Question 46 tests the linear independence of the following set of functions. We did 4 set of functions in the previous video. So in this video we will be solving next 3 questions given. So e raised to x, e raised to minus x, and sin ax. So given 3 set of functions, so Wronskian is e raised to x, e raised to minus x, sin ax, and e raised to x minus e raised to minus x, cos a into cos ax, and e raised to x, e raised to minus x into a square minus a square sin ax. So this we can take e raised to x and e raised to minus x common. So this becomes 1, 1, 1, 1 minus 1, 1 sin ax, a cos ax minus a square sin ax. So we can do some row operation. R2 equal to R2 minus R1 and R3 so Wronskian becomes e raised to x into e raised to minus x is 1, so that was gone. So R1 remains same, 1, 1 sin ax. Now this becomes 0, this becomes 0, minus 1 minus 1 minus 2, and 1 minus 1 0. So a cos x minus sin ax, and this term minus ax square sin ax minus sin ax. So this is, if we expand, minus 2, so we get this as minus 2 sin ax, and minus 2 minus, if we take minus common out, so minus sin ax as common, we get a square plus 1. So we can see that Wronskian is not equal to 0 for many x. For many x, Wronskian is not equal to 0. Only in certain conditions, certain values for x, Wronskian becomes 0. So it is not identical to 0. So we can say that, therefore, given set of function are linearly independent. So we checked C. Now we'll go do F. E raised to x, x e raised to x, sin hx. So finding, we will need derivative of sin d by dx of sin hx, and this we know that is cos hx. One second. So that is cos hx, and we need one more derivative to find the Wronskian. We need dx square sin of hx, which is dhx of cos hx, which is equal to sin hx itself. So we will be using this in finding Wronskian w of x. Sorry. So this becomes e raised to x, x e raised to x, sin hx, and e raised to x itself. This becomes x into e raised to x plus e raised to x cos hx. So this e raised to x. So this becomes x e raised to x plus e raised to x plus e raised to x plus 2 e raised to x. And sin hx. So if we perform R3 equal to R3 minus R1, we get w of x equal to, just first column changes, e raised to x, e raised to x into x plus 1 cos hx, and this becomes 0. This become 2 e raised to x, and this becomes 0. So we can expand it, minus 2 e raised to x into e raised to x cos hx minus e raised to x sin hx. So taking e raised to x outside, we get minus 2 into e raised to 2x into cos hx minus sin hx. So this is not equal to 0. Wx is not equal to 0 for all x. So this is not equal to 0 clearly. For except when cos hx is equal to sin hx. So only in that values of x, wx is equal to 0. So since wx is not equal to 0 for many x, then we can say that therefore given set of functions are linearly independent. So that is the solution to f part. Now let's do g. G is last one, sin 3x, sin x, sin cube x. So g sin 3x, sin x, sin cube x. So we don't have to find the Wronskian here. It's pretty straightforward. So Wronskian will become too complicated. So we know that the formula for sin 3x is sin 3x is equal to 3 sin x minus 4 sin cube x. This is the formula for sin 3x. So since we can bring everything to the LHS and say sin 3x minus 3 sin x plus 4 sin cube x is equal to 0. So this is in the form c1 sin 3x plus c2 sin x plus c3 sin cube x. Sin cube x. And just sin cube x is equal to 0. So we already have, since this equation satisfies, this equation is equal to 0, we can say that for c1 equal to 1, c2 equal to minus 3 and c3 equal to 4, this equation becomes 0. Since we have since 1 is true, we can say that c1 equal to for c1 equal to 1, c2 equal to minus 3, c3 equal to 4, this equation 2 becomes 2 is equation y is equal to, sorry, so we can, I just made a mistake there, that's why y is equal to c1 2 2 is equal to 0 or y equal to 0. So we can say that by the definition of linear dependency, we can say that this is linearly dependent. Otherwise, we should, if it was linearly independent, y is equal to 0, y is equal to 0 should have been true only when c1 equal to c2 equal to c3 equal to 0. For no other values, this y should not be 0 for if it was linearly independent. So we can say that therefore by definition, therefore linear dependent. We could have found out the Wronskian, but it is too complicated. This is pretty straightforward question. So this is the solution. So we have found out solution to E, F and G, all three. So question 46 is completed. This is the solution for E, F, and I'll just go through the steps once, and G. Okay.